So we also have a few pretty unique graphs. These don't come up a lot, so I'm not nearly as concerned with your ability to name them or know their domain, but it is good for you to recognize that they exist. This is basically going to be half of a rose curve. We call these Leminscates. So Leminscates. And it always starts off as r squared. But basically, this is going to end up looking like infinity. So 4 is going to go all the way out to 4 on this side. And then we're going to go negative 4 on this side. You basically end up with this shape right here. All right, so pretty interesting, and we can find area, and we can find slope, so we can do some calculus-oriented things with that. But we want to pay attention to the r squared being part of that process. I am going to show you what this graph looks like whenever we build it. So this one's going to be pretty similar. So you're going to have this little loop and then this little loop. That was a terrible drawing. Let me try one more time. You're going to have this little loop. You're going to have this little loop. There we go. Close enough. But I want to show you what it looks like whenever we draw it in Desmos. So you can see it there. This is actually from 0 to just pi over 2, and it is half of a rose curve. So notice that these are both happening at the same time, and it's because I have them as positive root and negative root because I can't graph r squared the way that I have my Desmos set up. So these are both building at the same time, and then that's kind of where they land. So pretty neat little graph. We also have this thing called the spiral of Archimedes, which is cool. So it's not something that you see a lot, but this is the spiral. This is just r equals theta, and it just goes on and on and on. So you can kind of see what that looks like. I have only gone from 0 to pi over 12. That's why it stops right there. But it will just go on forever and ever if my domain continued. So I'll give you just a little sketch of the spiral of Archimedes when r equals theta. So you kind of have, you're going to start at the 0 and just kind of circle your way out. I'm not going to pay too much attention to the coordinate points there. I just want you to get a feel for the shape. So spiral of Archimedes, just cool, all right? Not anything crazy that you're going to have to memorize or anything, but something that you might want to just be aware of. Won't see that on the AP exam, right? So not AP. Okay, let's go ahead and write just a quick note about these Leminscates. All right, so Leminscates are half a rose graph with 4 petals. So it's always the half, right? Looks like an infinity symbol. It's had some similarities to that for sure. Right? And then one of the things you do need to pay attention to, last little thing here, is that there's always a 2 theta argument. So you're always going to see 2 theta on the inside to be able to produce a Leminscate. So now you're a little bit more familiar with these graphs. Some of them you've seen, some of them it's been a long time, some of them you're familiar with. Maybe it's brand new information. But we do need to be somewhat comfortable with what they look like, as well as some of the nuances like the domain and the symmetry, things like that we're going to need to pay attention to so we can do the calculus part.